the first scenario, which is going to cover spear phishing, lure sites, and credential theft. I will pass the stick to Gil Cohen, the research director within CYE, who will present together with Antonio the scenario and will take us through the first steps. So, Gil, the floor is yours now.
Thank you, Yochai. But first, I'll give you permission to speak to Antonio. He's going to explain the first scenario. Antonio.
Okay, thank you, Gil. I'm Antonio Formato. My role is a technical specialist, security and compliance at Microsoft Italy. Please give me just a few seconds to share our disclaimer with you. In today's webinar, we'll show you some attack techniques and tools used in offensive campaigns. It's understood that they are shown as examples, tests, and training. So we share this content for training purposes only, as part of our training day. So I will describe the first scenario that we have conceived, and we will show you 2 points of view. The first one, potential attacker, then the organization that defends itself. So basically, the attack comes to life from a phishing email campaign that tries to induce the targeted user to enter his or her credentials, leveraging a fake Microsoft login page quite similar to Office 365. So once credentials have been obtained, the attacker prepares himself for the intrusion phase. We will show you how, by abusing the credential and without any particular precautions or hardening, there are possibilities to compromise other users in the same organization by, for example, obtaining the global address list and using it as a basis for a password spray attack. So the next step is the data exfiltration, leveraging inbox forwarding and the attempt to endpoint compromisations. Each step of this hypothetical chain will be addressed with all the details regarding how, with the Microsoft technology, we can implement prevention, detection, and response actions. So now I give the floor to Gil Cohen. Thank you.
Thank you. Hi, everyone. I hope you're not mad at me because I'm presenting from here and you are all at home, but we are in a serious conference, so let me move to my office. Yes, this is better. So my name is Gil Cohen and I'm a hacker for the last 15 years or so. And today I'm going to show you several demos, starting with the demo that Antonio just explained of spear phishing and credential test. I'm also a research director. I'm a research director in CYE, and I'm also the founding member of the hacking section, the 21, together with Ruby, and this is how we met. So let's start. Okay, so we're going to start with Kali Linux. This is a Linux distribution for hackers. It comes pre-installed with multiple tools, and we are going to use some of these tools in all of our demos. This is a free distribution. Anyone can download it and activate all of the tools that I'm showing you, but it is important to mention that this is for educational purposes only. We do not want you to go and do the same thing that we do and we show you here in real life, because it's probably illegal and not nice. So please don't do it at home. So first, I'm going to show you a very nice utility that is called Hidden Eye. This is a nice tool that enables you to create a phishing website very, very easily. Let me show you just how easy it is. Okay, so let's start. This is a tool that you need to only answer a few questions, and as soon as you do, everything starts. Okay, so this is for educational purposes only. And this is the main screen. As you can see, this is a very nice tool that comes with the pre-prepared login mechanisms that looks very real. So you have a Facebook fake login page in Google and many others. And we are in a conference with Microsoft, so let's choose Microsoft, which is option number 12. We want to add key logging options, capabilities, which means that the tool itself will be recording the keys that are entered by the victim. We don't want any other advanced options such as fake Cloudflare protection page. Or emails. Now, in the successful phishing attack, you want the attack to have a clear flow, that the victim won't understand that he was just attacked. And in order to do so, usually what hackers do is right after the victim gives his credentials, he's usually being redirected to the real page, to the real Microsoft login page. So in this example, I'm going to redirect to the login page of Microsoft Online. Port number 80. And this is a very nice option by Hidden. If you are a malicious hacker and you want to create your own phishing website manually, you need to copy and create your own fake login page, and then you need to find the host provider, meaning you need to find the server where the website will be stored, the fake website. And this tool not only giving you the fake login page, it also gives you an option to automatically create your own site with a specific internet service provider, or in this case, servers. So in this example, I'm going to select one of these servers, host servers. And that's it. You can see this is the URL, the address of our fake website, and I'm going to use it in our next step of the attack. So now let's send the email. So let me open another Kali session. And now I'm going to send the phishing email. But before doing so, let me just edit the page, the mail that is going to be sent. Okay, so I'll use the editor. Oh, sorry. Okay, so this is our phishing email. Hey, your credentials have been expired. Please update your security info, but click in here. So I'm just going to delete this old link and paste the new one. And that's it. We are pretty much ready. So now what's left for me to do is to send the actual email. So first let's set the subject, help desk, update, credentials expired, for example. And we are going to send it on behalf of another user. This is in email servers that are not properly configured. You can actually fake the from field and send it from anyone you would like to. So the first in real life scenario, the first thing that we will do is a reconnaissance. We're going to gather information about the organization that we are going to attack, and some of the information includes, for example, email addresses of the people that work in the organization. And in real life scenario, I would probably choose the IT admin address in order to fake an email that looks like is arriving from him. So let's now choose our victim. Sorry. And all what's left for me to do is to point out to the phishing email. Okay, that's it. So now let's see what the victim is seeing. So this is the victim machine, and this is the inbox. And you can see that the phishing email has just arrived. Oh, okay. And here is the link, and here's the phishing email. And obviously, this is just a demo, so I haven't covered the link, and it looks suspicious, but there are multiple ways of doing so. For example, bit.ly URL shorteners, or even writing an URL that looks legit, but when you click it, it points to a different URL. This is possible with HTML and rich text formats email. So there are multiple ways of hiding this link, but for now, for this demo, we'll settle with the ugly link here. So let us click it. And now, all what's left for me to do is to try to log in to the account. And the password is this is the password. And as you can see, now I was redirected to the real login page. This is for the flow that I was talking about. You can see that the victim would probably think, oh, I've entered the wrong credentials, so let me just try it again. And as soon as he does, he gets logged into his real account. And he doesn't know that he, in fact, was visiting a phishing website, and he just gave his credentials to the hacker. So this is a very nice flow that makes the attack less visible. So now let's go back to our hidden eye tool, and as you can see here, this is the keystrokes, and here is the email and password. Very nice. So now we have the email address and the password of the user that was just lured by our attack. And let's see how we can use it for our benefit. So in the next step of the attack, I'm going to use a tool, a PowerShell tool that is called Mel Sniper. And this is a very nice utility that enables you to do many things I'm going to show you now. So in order to start, let us first import this module. Oh, sorry. So I'm going to import it first. And now I'm able to issue commands. So the first command I want to issue is to get a global address list. The global address list is a list in every email server that contains the email addresses of all of the users on this server. And if this is accessible, for example, if I have the credentials for a single user, I can use it in order to log in with this user and get additional email addresses. And this is very good for widening the attack and attacking further users and for internal reconnaissance. So let us activate this command right now. So the username is user5. The password is this one. And now let us put the output file. Okay. So I issue the command. Oh, just a second. Let's try it again. I issue the command to log into the Outlook Web Access interface and to get the global address list and to put it in this file. Let's wait for it for a few seconds. And as soon as it finishes, I'm going to activate another command of Mel Sniper and another kind of attack, which is called password spray. Password spray is an attack where you try to change the username when you try to hack into, but use the same password. Traditional monitoring solutions try to, for example, to monitor a single username hacking attempt. If you try to choose the same username with different passwords again and again, it fails to log in, this triggers a monitoring event. A more modern approach for hackers in order to prevent monitoring systems from alerting about these attempts, and also to prevent user lock, is to use the password spray technique. And this technique, you select a single username or a set of a single password or a few passwords, and you try this password with many usernames, and you hope that one combination will be correct. And this is what I'm going to try to do next. But let me just.
Gil, I think you are missing a W in the password.
Ah, yeah, you're correct. Password. Nice catch. Okay. You should be a hacker. So now you can see that all of the users are being enumerated. And it's going to finish in a few seconds. And then we'll go on with the password spray. Okay, just a few seconds. You know what, let me just stop it for now. Okay, so the next step would be to invoke the password spray attack. And I'm going to configure it once again. So I'm going to use the same set of credentials. Let's speed it up a little bit.
Password with 2, no?
No. It's we have 2 passwords for this, but it's okay. Okay, credentials.txt. So this attack takes more time. Oh, sorry. Let's try this again. Oh, I forgot. It's I got confused with the different command. So let me just write it down again. In this command, I need to provide a user list and not a user name. So let's try the same password that we just discovered with a different set of users. Again, space here. Okay, so now I just issue the command to perform a password spray attack with a user list that is located in this file with this password just we just discovered, and we hope that maybe this password is being reused by additional users. This is a common practice in many of our clients. We see that, for example, IT department configure a local admin or default password for the entire organization, and many users actually choose this password in order to identify themselves in front of different systems. So this is what we are going to try now. This attack takes a lot of time, so I'm going to leave it for now, and later on we'll come back and see the results. The next step I'm going to do is to activate another attack, which is with a utility that is called Ruler. This very nice tool is allowing me to add rules for the victim, like mail handling rules. But first, let's log into the victim's account. And in order to do so, I'm going to use the Tor browser. Tor is an anonymous browser, anonymous network. This automatically connects to different servers that enables the hacker to mask his real IP address, and as a result, mask his identity. So I'm going to use this in order to try to log into the victim. Okay. So let's log in now. Okay, so now we are logged in as the victim from a different set of IP addresses. Sorry, and this is the security level of. You can see here. Let's, for example, search for IP location, just to show you what Tor is actually doing. You can see here that I have an address in Germany now, and I'm logged in from to this victim account from a German address, although I'm located in Israel. And if anyone would check the logs, he will see that I just logged in from Germany. Although Tor addresses are known, and there are actually monitoring rules for Tor addresses that this would probably pop up in the monitoring systems. So let's go back to our victim. So here I have access to his emails, and I can obviously steal emails from the and compromise his privacy. And I can also try to, for example, let's see all the settings. I can try and add a forwarding rule, malicious@hacker.com or whatever. And I can steal his emails in a persistent manner. Another thing that I would try to do is to, again, activate the ruler utility in order to add rules, and not forwarding rules, but more advanced rules to the user's mailbox. So let's go back to our Kali machine. And this is the ruler utility. And let's first try to log in with the credentials. Okay, so now I just use the ruler tool in order to log in with the credentials and just display all the current rules. And there are no rules, but I can see that the login process was successful. So now instead of display, I can issue a different command. And for example, add a new rule. And this very nice rule, I would search for the word trigger in the subject. And if the word is found, then I'll tell the Outlook of the victim to go to a specific address and activate a batch file. A batch file is an automated file that contains a script Okay. So now the rule was added. And to finish our attack, let's go back to the victim. Okay. So now if I'll look at here at the rules. Oh, sorry. Let me just reactivate Outlook. Okay, you can see that my malicious rule was added remotely by the attacker. And let's see what are the consequences. So in order to activate my attack, I'm going to go back to the attacker machine and to send an email from the victim to itself with the word trigger. Now let's wait for a few seconds. Okay, so the email has arrived. And we'll wait for a few seconds now. The malicious rule should be activated any moment now. Let's pick it up. Let me run the rules manually now, but it's usually, oh, I don't need to run it manually even. It just ran on its own. There are a few seconds that the email is still there once I send it, but for example, I can try to send it during lunchtime and hope that the victim won't notice. And as you can see, the rule was triggered and the batch file was executed on the victim machine. So now, instead of just having access to the victim's email inbox, I'm able to activate commands on his machine. And instead of just this nice message, I can execute malicious files in order to take over his machine and get a foothold on the organization that I'm trying to attack. And on the next demo, I'm going to show you what can be done with this foothold. So let's go back to Yochai.
Thank you very much, Bill. I think now we want to see how we can actually prevent this or detect this from happening. I'll pass the stick to Mara, which will start taking us through the different stages of the defense against this type of very interesting attacks, Bill. So Mara, the stage is yours.
Thank you. First of all, I want to introduce myself. I'm Maura, and I'm Microsoft Technical Specialist Security and Compliance here in Italy. And we will see now the first part for the first scenario. We have seen with Gil that our simulation starts with a spear phishing email, as most of cyber attacks do today. We simulate a spear phishing email by simply using postfix service on our attacker machine. So as you can see here, we can just send this
Mara, you are muted. Maybe you can activate again your voice. We cannot hear you.
Oh, okay. Okay. Can you hear me now?
Yes, thank you.
Okay. I start again. Let me say. Okay, I'm Maura from Microsoft. I'm a technical specialist, security and compliance. And now we will see the defense part of the first scenario. Our simulation started with a spear phishing email, as the most of cyber attacks do today. We simulate spear phishing email by using postfix services on our attacker machine. As we have seen with Gil, we can run this command to send an email that contains specific URLs, and by clicking these URLs provided in the email, the attacker is trying to mislead the users and convincing them to get their credential. So by using Exchange Online Protection and Office 365 ATP, we provide an enterprise-grade level protection for all email flows. That means the inbound, outbound, and inter-organization as well flow. Our email security stack that leverages de facto standards techniques such as IP and domain reputation, anti-malware, and also the artificial intelligence and machine learning based detection such as sandbox, URL detonation, advanced anti-phishing engines, and anti-impersonation, we are able to stop most of the malicious email, reducing the likelihood of compromission. Obviously, you can't ignore the human factor of cybersecurity. So we recommend to start awareness programs for your employees. This is why with Office 365 ATP, we also provide simulation tools. Now, let's move on the machine of the victim one. As you can see here, the email is not delivered on the user inbox, but it is quarantined. So if we switch back on the admin portal, we can go on the Security and Compliance Center. Under Threat Management and Review, we can click on Quarantine. And here, we can see here the email that we just sent. Clicking on it, we can see some details. So we can see the recipient email, so the victim1@labcorp.it. And we can see here the reason why the mail was sent in the quarantine. And this is for the fact that it is flagged as phishing email. We also see that the sender address is user2@labcorp.it. That it means that the attacker used impersonation technique. We also click on the preview message in order to use a sandbox to see how the email can be shown by the end user. And also, we can click on the links, and we can see that they move the end user to a login page that is very similar to the Microsoft one. We can also click on the view message header. In order to see the message header, we can copy it and we can send it to the Microsoft Message Header Analyzer in order to analyze it. Also, we can click on the Explorer tool, and we can filter the view by phishing email. And here we can see also the same email that we just sent. Clicking on it, we can see some details again. So the victim one, labcorp.it, is the recipient. We can see also some other details. So again, we can see that the mail was sent to the quarantine as for the spam policy, and the delivery action was blocked. Now, let's try to deliver the malicious email anyway by using a previously created Gmail account. So let's switch to the workstation one of the attacker, using, of course, the same content. So I can compose my email, and I already created here my template that is the same that we just sent using the commandlet. Now we send the email to victim 2. I just copy the subject, I copy the body, okay, and just send. Now, if for some reasons protection services is not able to catch malicious email arrives in the victim inbox. When the victim opens the email message and clicks on the URL in the email message, the Office 365 ATP Safe Links feature immediately checks the URL before opening the website. The URL can be identified as blocked, malicious, or safe. So just click on the first link, and if the URL is to a website that has been determined to be malicious, a warning page like this one opens. So we can see here the alert: this website has been classified as malicious, so we recommend to do not open the website and go back. But Office 365 Safe Links also provide more flexibility to our customers, and to do that, it simply provides a static list of URLs that must be blocked. So if the URL is to a website that is included in the organization's custom blocked URL list, a warning page opens, and as you can see here, the alert is very similar, but a little bit different. The website has been blocked per your organization URL policy. So again, we recommend to do not open the website and go back. If we go again to the Explorer, we can also click on the URL tab, and here we can see also some other links. For example, we can see here the labcorp.azurewebsite.net. That is one of the URLs present in the email. And here we can see all the emails that contains this link, and when the recipient received this kind of email. Now, let's assume that attacker has gained user credential by leveraging a well-done email phishing campaign. So the next step would be to using a stolen credential to spread over the customer's cloud identity and services, hoping to get access to the global address list. In order to do that, we use Mel Sniper tool. Mel Sniper tool is a penetration test tool for searching through email in a Microsoft Exchange environment. It can also be used by Exchange admins to search the mailboxes in a domain. And it is not a malicious tool, but it can be used in a malicious way. It's powered by PowerShell, and if used as hacking tool, Mel Sniper can be used to obtain account names or global address list, and it can be used for password spraying against Exchange servers or Exchange Online. So now let's try to get victim one global address list. Again, just import the module. Okay, and now just copy the commandlet. There we are. Okay, how to block and how to detect this technique used. First of all, Mel Sniper needs credential to get access users' mailbox, but it uses legacy authentication protocol as most of the similar tool in this area. That said, due to the increased risk associated with legacy authentication protocols, Microsoft recommends that organizations block authentication requests using these protocols and require modern authentication. When the attacker runs the command to retrieve the global address list against victim one, he uses Exchange Web Services as authentication protocol. If we do not block the legacy authentication protocols like this one, the attacker will be able to run the command and gather the global address list. Let's try now to get victim two global address list. So I just copy the second commandlet and I run it. Okay, in our demo, we deployed a conditional access policy to victim 2 in order to block access to Exchange Online if he or she logs in using legacy authentication protocols. So when the attacker attempts to gather the global address list using the victim 2 credentials, he finds this kind of error. So let's see now how conditional access works and how we can configure the policy. So let's switch to the Azure AD admin portal. Click on Security and Conditional Access. As you can see here, we can create the CYE Demo 2 policy. Clicking on it, we can see how we have deployed it. First of all, we assigned the policy to specific users. In particular, we included only the victim 2 and not the victim one, just to let you see the differences between victim 2 and victim 1. Then we selected as Cloud App, of course, the Exchange Online. And then we selected as condition the fact of using as client apps all the clients that are different from the modern authentication clients. This means that we are catching all the clients that support legacy authentication protocols such as Exchange Active Sync and other clients. For example, the Exchange Web Services. For the access controls, we just block the access. So when a user tries to log in to Exchange Online using Exchange Active Sync or other clients, we just simply block the access. In fact, if we go under monitoring and we see the logs of the sign-ins, we can now see here that the victim 2 failed to log in to Exchange Online. If we click on it, we can see that again the status is failure, and the reason failure is access has been blocked due to conditional access policies. If we click on conditional access tab, we can see here that the policy that blocked the access for the victim 2 is the CYE demo 2 policy. Okay, now let's assume that the attacker again retrieved the global address list. The next step is to use this global address list to run the password spray attack here. And during this attack, it tries to log in to all the addresses that is included in the global address list using the same password. As we have seen before, enabling conditional access policies that blocks access from clients based on legacy authentication protocols could be one simple step that helps security operation teams in avoiding attackers using tools like Mel Sniper. Also, in addition to this, we can also monitor this kind of attacks using the Azure AD logs that can be ingested by Azure Sentinel. So let me switch to the Azure Sentinel portal. Okay. Azure Sentinel is our security information and event management and security orchestration automated response as a service. It delivers intelligent security analytics and threat intelligence across the enterprise, providing a single solution for alert detection, threat visibility, proactive hunting, and threat response. Azure Sentinel ships with built-in hunting queries that have been written and tested by Microsoft security researchers and engineers. Threat hunters can also leverage a GitHub repository of hunting queries provided by Microsoft researchers, internal security teams, and partners as well. With Sentinel, we can also create a custom query that filters and aggregates sign-ins logs from Exchange Web Services client apps and failed due to invalid users' username and password. So Azure Sentinel uses analytics to correlate alerts into incidents. Incidents are groups of related alerts that together create an actionable possible threats that you can investigate and, of course, resolve. So in our case, we created this rule that if detects more than 3 results, triggers an alert and creates the incident. So in this case, we can select the alert related to password spray, as we can see here. Clicking in on it, we can see that are related to this incident 40 events, 10 accounts, and 1 IP address. If we click on this button, investigate, we can see the graph that is related to this incident. In particular, we can see here that we have 10 users involved that tried in the same time to connect to Exchange web services using this kind of client. And the other strange thing is that they tried to do that using the same IP address. So this is the proof that they tried to use this tool just simply to have a password spray attack. So now I just give the word to Antonio in order to see how to avoid the attacker use these credentials to create some damages.
Thank you, Laura. Antonio, the floor is yours.
Thanks, Laura. Are you seeing my screen?
Yes, thank you very much.
Okay. So let's take a brief point of our journey. Attacker has stolen the user credentials and has used them to get the global address list, doing a password spray attack. Next step. So once attacker has username passwords, he must decide how to move forward, driven by goals he wants to achieve. So we'll see basically two possibilities. First option, once the attacker finds at least a couple of credentials, he can use them to access to the user's mailbox, create an exchanging forwarding rule to exfiltrate the user's data. Usually, she accesses these by trying to hide his IP address, for example, using a Tor browser or similar tools. So, how to protect the organization? First of all, we could disable the ability to create forwarding rules. Wise choice, but not always applicable. The second point is we could apply a multi-factor authentication if and only if the access can be considered suspicious. So basically, it's here. How do we identify attempts to access to consumer service that can be considered suspicious? With the Azure Active Directory identity protection and conditional access again, we can leverage the evaluation of the risk of the user session based on our threat intelligence service named ESG, Intelligent Security Graph, and machine learning to provide behavioral-based detection. Please notice this sign-in risk configured. The risk signals can trigger remediation actions such requiring user to sign in again, perform multi-factor authentication, reset the password, or blocking the user until an administrator takes action. So first practical consideration or suggestion, please enforce multi-factor authentication. So let's see what will happen if I try to abuse the credential, as in the GIL demos. So I start the Tor browser. Okay. On Outlook Web Access. And I enter the stolen credentials. So victim 2. So authentication is successful, but now I'm asked for a multi-factor authentication. So if an attacker is trying to use the stolen credential to define, for example, an email forwarding rule, it's possible to identify this suspicious behavior asking for a multi-factor authentication. Our security tools are also able to track and detect if a suspicious inbox forwarding rule has been configured, and it will be useful to have a full control on what's going on with the email flow. So now let's move on. What if the attacker has obtained target user credentials, for example, via phishing, brute forcing, sniffing, or something like that, but he doesn't have access to the workstation? Basically, this raises the question of whether a domain username and password could be useful without a workstation to authenticate against. Most organizations use Exchange for email service. So anyone familiar enough with Outlook will know it has a rules and alert section here that allows the user to automate actions based on message criteria. Most of the available rule actions are related to modifying the mailbox, moving messages, categorizing items, and so on. However, a few more, let's say, questionable actions stand out, namely start application. We decided to show you this kind of technique mainly because it starts from the cloud and lands on the endpoint, and because we have seen it used by several threat actors in the past few years. Taking into consideration that our threat intelligence group has discovered several tools to abuse the Outlook's common features, functionality, features, and so on. So in order to execute payload or gain persistent on the machine, we use the ruler tool to showcase this approach. Prevention is definitely the best cure. So in this case, prevention means to be sure that you have deployed all the available security patches. What could happen if the victim doesn't have a fully patched Outlook client? So the attacker runs the ruler attack that, as we have seen before, creates a rule, and when an email with a specific word in the subject arrives in the mailbox, downloads a batch file from our command and control server, and delete the email to hide its track and run the malicious code. So let me run the ruler against victim 2. Just a moment. Okay. As you can see here in my screen, a ruler tool against victim 2 doesn't work. Why? Since Maura has deployed the conditional access policy to stop a legacy authentication protocol, the ruler or similar tool doesn't work anymore. Let me run the tool again against victim 1 and victim 3. Okay, I'm adding the rule for victim 1, and in the same way as we have seen before for victim 3. In our demo environment, victim 1 hasn't installed the security patch. So if the attacker, attacker's rule, if I go here, I can see the malicious rule synchronized and up and running, let's say. But on victim 3, out client has the security patch installed, so the rule here is listed, but it's disabled and present errors, so it can't be used for establish persistencies or for some way running malicious code. Okay, so let's move on our tool. So software patching is a crucial process to address and to manage over time, for sure. So in order to be sure that no vulnerabilities can be exploited to cause any kind of damage. So now it's time to add the detection considerations to our security journey, to our security story. With Microsoft Cloud App Security, our Microsoft CASB provider, we can create and use policies to detect specific cloud attacks and to take remediation and containment actions. So in this case, I have I can show you this alert. Basically, we obtain information about the attack detected, the user involved, the cloud service involved, the IP address, in this case classified as a risky IP address, and I can also access to the raw data. Basically, this is the log, the raw log generated by Exchange Online in this case. Once, let me show you the policy section. Okay. We have several rules, alert based on behavioral analytics, threat intelligence, DLP, anti-malware, sandbox, and others. Let me check for ruler. Okay. So basically, this is how a policy, an alert policy is defined. Once the ruler attack is detected, we can automatically apply some kind of governance actions, like suspending the user, requiring the user to sign in again, or confirm that the user has been compromised. In addition to this, security admin can leverage the Microsoft Power Automate tool, as you can see here. So what does it mean? SOC teams are looking for solutions that basically help how to automate processes where possible to reduce, for example, the number of incidents that require their direct oversight or some kind of interaction. Cloud App Security now integrates with Power Automate to provide the centralized alert automation and orchestration of custom workflow. It basically enables the use of an ecosystem of connector to create playbooks that work with the systems of your choice, your processes, and enable, generally speaking, the organization to automate the triage of alert. So we have a gallery of several hundred of already integrated connector. Some example are, for example, routing alerts to different SOC units or automating the ticket generation in your management tool. In our example, when an MCAS alert has been raised, we run a flow. We ask to get the user details, then we send an email, in this case to the user's manager, and SOC analysts sometimes require an approval from a manager to execute actions, for example, disabling the user account. So in our case, we have this kind of flow defined. Based on manager action, we can automate a ticket creation, for example, in this case, ServiceNow, and we post a message in the in Microsoft Teams. So I would like to show you something here. As you can see, I've got an email message asking for my action. Just a moment. So I'm not sure about disabling user in this case. So I'm clicking here, not sure. And Power Automate in this case sends the Teams message to incident response virtual team here. This is the message, and creates a ticket in ServiceNow platform. So before giving the floor to Simone, I would like to thank you again for your attention.
Thank you very much, Antonio. Simone, I pass the floor to you to finalize the protection element of this scenario.
Thank you, Antonio. Thank you, Kai. Can you see the screen? Can you hear me?
Yes, very well.
Cool. Well, thank you. First of all, let me thank CYE to have invited us. Just one word to introduce myself. I'm Simone Peruzzi, and I'm an account technology strategist in public sector for public sector in Italy. In these few minutes, I would like to provide you an overview of passwordless authentication, considering that it's becoming the best way to keep user authentication experience secure, but most of all, simple. In fact, it is not a coincidence that that has been mentioned by World Economic Forum report in the latest report. In this latest report, it evidenced that the most efficient way to fight cyber criminals is to forget user authentication through password. Living without password means improved life. For example, no stress in memorizing it, steal it, or update it regularly. And moreover, with higher security protection levels. So in this few slides, I would like to show you the three kind of method of authentication right now present in our systems. You can see the password at the lower right, and the password is the nowadays user authentication that we use. Most of our people use no password right now. It provides low security, but it's convenient. Low security, and you saw in the previous demo of Antonio of Maura about password spray and phishing. The second kind of user authentication is password plus two-factor authentication. And this is something that has become pretty popular. The two-factor authentication higher the security level, but this brings some inconvenience. The inconvenience is the user experience. Probably you heard about that. Many customers complain about the two-factor authentication because it's stressful. You have to insert an additional factor authentication, and of course the user authentication experience is not so easy. The real transformation happens with passwordless authentication. Password authentication is authentication that in the Microsoft approach can land in three typical ways. Through Windows Hello. Windows Hello is a biometric authentication that has been introduced with Windows 10. Right now, is it available in several devices on the market. Microsoft Authenticator, that is an application that is that can be installed on iOS or Android, and this application can provide an additional way of authenticate the users. And then the FIDO2 security keys. The FIDO2 security keys is an open standard. Microsoft embraced the FIDO2 last October in a public preview. The FIDO2, what does it mean? The FIDO2 security keys means authentication through USB key that can be biometric, or through NFC badges and wearables. Through several vendors, right now there are several vendors that are working with us to enable this user authentication scenario, like Ubico, Phishing, Ensurity, AWBM, and HID. Why eliminate password? Well, mainly because password, as we said, are hard to remember, are difficult to enter even in several devices, several devices that we have at home or at work. And even the strongest password are phishable, easily phishable, that you saw in the previous demo. So we want to provide a better user identification, probably also resolve the problem of self-service of password reset. And we know many customers are stressed by this, help desk customers are stressed by this kind of approach. and also want to provide a simple user authentication to the users. This is all without forgetting the multi-factor authentication. Multi-factor authentication because it prevents the majority of breaches and can help through the USB key to provide a really highly secure authentication to the users. But what does it mean, FIDO2? FIDO2 is the latest specification of a non-commercial alliance, FIDO. FIDO stands for Fast Identity Online. FIDO was born with the objective to develop an open standard for secure authentication on World Wide Web. The heart of FIDO2 mainly is a user authentication through cryptographic authentication, like, for example, biometric or PIN factor, and or external authentication, FIDO wearable, FIDO keys, wearable or mobile devices. This is our remote trusted device. In our case, is Azure Active Directory, as we said. In fact, here you can see as a simple diagram of what does it mean FIDO in a simple user experience. We have the FIDO2 authenticator, in this case, a local verification through the USB key. We have a platform that right now is Windows 10, starting from version 1809 or more. And then we have the relying party, the authentication protocol that is talking with the relying party. So merely the FIDO2 is composed of two protocols. The client to authenticator protocol that verify the USB key, and the web authentication protocol that verify the authentication from the platform to the relying party. Why we are, and these are two protocols that enable the stronger authentication. The question is why I'm inserting here relying party. Well, because we are talking here about Azure Active Directory that right now, as I said, is in public preview. But of course, FIDO is an open standard. So right now is supported by many other vendors, Google, Amazon, PayPal, and so many others. So it's really an open standard that can enable a simple user authentication experience through many vendors. What are the three benefits for FIDO2? So for sure, it's a standard base. It works with the majority of the browsers and the majority of the devices. In this webinar, I couldn't show you the user experience, so I tried to build a demo about what could be the user experience of using a passwordless authentication. Here you can see my USB key. It's a Ubico key. It's a not biometric key. And I try to access myprofile.microsoft.com. I insert the USB key, and it asks me for a PIN code. I insert the PIN code on my laptop, and it asks me to touch the USB key because it wants to verify that I'm not a bot. So it's not a biometric verification, but it's a presence verification. And in this way, I'm directly connected to myprofile.microsoft.com without inserting any password. Many customers, when I show it to this demo, the main question is, yes, but why I have to insert a PIN code? Well, I have to insert a PIN code because I said already, we are talking about multi-factor authentication. So it verifies something I own, in such case a USB key, and something I know, in this case the PIN. The user experience would be different with the biometric key. In this case, I'm showing you a demo of a biometric key and trying to log on to a Windows 10 device. I insert the USB key, and just touching the USB key with my fingerprint, I'm logged in the system. And in this way, without inserting a PIN, it verified something I own, again a USB key, and something I am, in such case a biometrics. So the multi-factor authentication condition is respected. So again, you see here the simple user experience that we can provide to the users. Of course, it's a strategy that can be enabled in short term, but needs time it's a path to toward the passwordless that start to deploying passwordless replacement methods to the users. It passed through the analyzing the application and also the logon of the various users to the devices, and toward the transition to passwordless deployment. So it takes time. It's a strategy that can help to leverage user experience, and we can provide additional documentation on how we can move to this strategy. So again, three good reasons for passwordless: user-oriented and convenient, saving help desk resources, because you can imagine how we can leverage the work of the help desk resources right now with this user authentication, and still offering a high protection with multi-factor. I have landed some resources here that you can benefit when you are offline. And thanks all for your time.